Hi everyone, and welcome to our What's New in SAP HANA Cloud webinar in Q1 2025. My name is Susan and I'm part of the product management team taking care of SAP HANA Cloud and SAP HANA. Today we will definitely not be able to cover all the innovations we delivered with QRC1 2025, but we will give you at least an overview over a few of the highlights of the release. If you are looking for a more comprehensive overview, I can definitely recommend taking a look at our What's New blog post and our technical documentation that will cover all innovations in more details. As always, I'm not alone in this webinar. I do have a bunch of my colleagues and product experts in the backend with me who will dive deeper with us into their topics for this release. With that, we're already taking a look at the agenda, and as always, we'll be starting with a small general update, taking a look at a few smaller innovations we will deliver this quarter, and then we're definitely coming to one of the highlights of our release. Our product expert, Shabana, she will give us an introduction to the knowledge graph engine that was announced at TechEd last year and is now finally delivered with the QRC1 release for HANA Cloud. After Shabana, we will have Christoph, who is giving us an update on the machine learning and natural language processing functions in HANA Cloud, including the newly released GenAI toolkit. After that, we will have Jan, who is giving us an update on the database modeling side of things. And we will close our call with Jose, who will give us an overview over the generative AI virtual assistant for administration in HANA Cloud. With this, let's jump right into the general update. We're starting with two innovations for our data lake. And the first one is a new application for data lake files within SAP HANA Cloud Central. With this application, it will be easier and more efficient to administer data lake files. This, of course, comes with a few key features. So let me mention a few here. You can now browse contents directly from HANA Cloud Central. You can do your file management, including uploading and moving files. You can also view text files like CSV data, JSON data, and text data. You can also perform point-in-time recovery and create and manage policy lists. Moving on to the next innovation, you are now able to create virtual table connections from the HANA Data Lake Relational Engine to SAP's Adaptive Server Enterprise. Okay, what does that mean for you? You can now define and query virtual tables connecting from your relational engine to ASE on-premise. This actually comes with a handful of benefits. It of course enables data tiering to the relational engine, and it allows you to offload complex analytics and reporting capabilities to improve the efficiency. You can of course also create and query virtual table connections. The next innovation I do have on my list for your general update is the ability to copy instances based on templates into existing instances. What does that mean? That means you can provision multiple instances of SAP HANA Cloud based on a single template into existing instances of SAP HANA Cloud. The benefits you will see from this is you can create QA systems from templates to ensure the consistency. You can provision multiple instances from a single template, and overall your instance management just becomes more efficient and effective. We're also adding a self-service to recover a backup from a source SAP HANA system to a target SAP HANA system. This gives you a few benefits. So you can definitely safeguard your data against loss. You can also intuitively create a quality assurance system from productive SAP HANA Cloud system, and you can keep your operations secure, efficient, and resilient. One tiny remark here, we will first deliver the command line option with our QRC1 and will deliver the UI version a few weeks later. Just a tiny piece of information. With the recent release, we're also enhancing our data center roadmap. We're adding 7 new data centers with the Q1 release. Four GCP data centers, one in Sao Paulo, Brazil, one in the Kingdom of Saudi Arabia, and two in Japan, one in Osaka and one in Tokyo. We're also adding two Azure data centers, one in central Canada and one in China North, and one AWS one in the US in Oregon. This actually allows your customers to pick the data center of their choice in the region and from the hyperscalers they are needing. Last but not least, for the general update, we're talking a lot about innovations today. If you want to be at the forefront of innovation, I want to recommend our early adopter care programs. We're currently running two, one for the knowledge graph engine. You will just in a few seconds learn more about it, and one for the various elasticity topics in HANA Cloud, like large instances, SQL on files, and elastic compute nodes. So if you want to get customers in direct contact with product management and development and bring your projects to reality, I can definitely recommend to register for these programs today. And with this, we're actually diving into the first innovation of this webinar, the first big one, the big bang of our release, the Knowledge Graph Engine. With this, I'm handing it over to Shabana for the next few minutes.
Perfect. Thank you, Susan. That was great set of general updates. And as Susan mentioned, I'll be talking in depth today about the upcoming Knowledge Graph Engine from Q1 of 2025. And I basically wanted to start off with a motivation slide on why we basically want to have a Knowledge Graph Engine in HANA Cloud. So yeah, just getting an introduction to that. I think when we just think about data in today's world, we are often talking about how much of data we have in hand, but also the real challenge is not just the volume, but also making some sense out of your data, right? So the customers, the businesses, they are generating vast amounts of information every second, but if you think of having your data without any structure in current AI kind of a world, connecting different pieces of data, that could become really tedious because you could really end up having a lot of data silos that don't communicate with each other. And traditional databases are also great at storing data, but they don't definitely understand the relationship between different entities in a much more intuitive way. So this is where I think knowledge graphs and the knowledge graph engine would come into picture. Like instead of treating data as isolated records, the knowledge graph is providing you an organized way of setting up your information that would highlight the connection, make it easier to find the insights, and also for our businesses to make the informed decisions. Just as a great example, I think on the previous slide itself, if you could see that picture there on the right, we have example of the Google's knowledge panel. So if you would just go and search for Hasso-Plattner, the Google is not just returning you a list of web pages, right? But it's instead presenting you with some structured summary, his background, his company related figures, and even common questions that would come up on people's mind when you have a search term like that. So this is happening because Google's knowledge graph understands not just the keywords here, but also the relationships and the concepts between them. So it knows that Hasso-Plattner is a person and he's associated with SAP and all the other business leaders that are connected to him. Now, just taking a little bit more onto the same slide here, why does this really matter for businesses? So you can think about how organizations basically handle their own data, right? So you have customer records, product catalogs, compliance data, financial reports. So all of these are often stored in different systems with no easy way to link them together. But knowledge graphs, as a part of the multi-model engines now, would provide a way to bring structure to this different kinds of entities of data that we are dealing with. And this is exactly why I think HANA Cloud Knowledge Graph Engine is very important. It would help businesses structure their data, connect relationships, and so much forth, basically powering a lot of AI-driven applications as well. And on the next couple of slides, we will take a look into some introductory concepts here, some of the words that you will keep on hearing a lot when we talk about Knowledge Graph Engine. just let's start with defining a knowledge graph. So it can be said as a smarter way to structure information by capturing the relationships between different entities. It could be people, places, concepts, or anything, even in the business world. So instead of just treating your data as isolated records, a knowledge graph is recognizing it and organizing it into a network of interconnected facts, which makes it much more understandable, not just for humans, but also for the machines, which is very important. And this would also allow the systems to, infer some new information and answer some more complex queries better than what the traditional databases have been doing. And with this, I think HANA Cloud is also getting modernized much more than a traditional database. And just taking an example there on the slide, we are looking at a small knowledge graph that is the movie Jurassic Park. So instead of just storing the movie's name in a table, here we are seeing a knowledge graph that is connecting the meaningful relationships here, like who directed that movie, which studio produced it, or when it was released, and even which movie is its sequel, and so on. So this structure is allowing us to ask some deeper questions to it, like some people could come and ask which other movies were directed by Steven Spielberg, and then this knowledge graph is able to connect all the movies that that particular director has directed and is able to give us back the facts that we need. And on this next slide, we have more concepts in picture, like some of the keywords again, RDF, which is the resource description framework, which I would say is the backbone of knowledge graphs, which is providing a structured way to connect and represent data here. So like I said, RDF is going to organize your data in a graph-like format that is defining the relationship between entities. So this approach is allowing your data to be shared, allowing it to be linked, and also reusing it across multiple platforms, and also making your data a key part of the semantic web and intelligent data integration that's coming along with the knowledge graph concept. And at the core of RDF, we have the triple-based structure, which consists of 3 parts. This is typically how your knowledge graph would be defined or designed. So we have the subject, which represents here an entity, like, for example, the movie, and the predicate, which is describing the relationship between the subject and the object. And then coming to the object, which is, again, related to the entity. So we have 2 set of entities here, which are connected by the predicate. For example, we have like the movie Jurassic Park is directed by, which is a relationship by the director, Steven Spielberg, which is, again, an object. And when we have this RDF and triples in place, to make this system work much at scale, we want each of these entities and relationships in RDF-based knowledge graph to have their own unique identifier, just like having primary keys in our traditional database, right? So they are called uniform resource identifiers in the knowledge graph world. So this is ensuring that the data remains consistent, and it can also be referenced accurately across different systems. It's like a pointer to your triple in a certain way. So by structuring your data in this way, RDF is enabling the businesses to create much more intelligent search experiences and even more AI kind of applications or AI-driven insights that is needed for them. And on the next slide, we have what basically is coming out with the HANA Cloud Knowledge Graph Engine. With all those introductions done, I think now is a good time to talk about what we are rolling out as part of the HANA Cloud database. So we are definitely adding the Knowledge Graph Engine as a new addition to the multi-model capabilities of HANA. That means it is bringing in the native RDF triple store support, and it is going to enable the Sparkle-based querying and updates. We will see about Sparkle in a bit. So this is going to allow the businesses to store their knowledge graphs in HANA Cloud alongside other traditional relational data or other spatial or JSON document kind of data that the businesses are already having in the database. So to make this more accessible, we have introduced the new SQL functions and procedures that is going to integrate, create an integration between SQL and Sparkle. So for example, we have a Sparkle table that is going to embed the Sparkle queries inside our SQL function, making it easy to retrieve the knowledge graph-based insights directly within the SQL layer itself. And then we have Sparkle Execute, which is again a built-in procedure. It's a way to run, again, the Sparkle queries embedded within it. And then we have SQL Table, which does the reverse, like it allows SQL query to be executed inside a Sparkle statement. So apart from all of this, we are also going to support the importing and exporting of the knowledge graphs in RDF formats, like the turtle files, the JSON, LD files, and so on. And we are also including flexibility for our customers to choose their response formats. It could be in JSON format or XML or CSV format, whichever would suit their use case. And from the consumption perspective, the engine is going to be designed to work with SQL and Python. It's going to be easy for the developers and data scientist community as well. And we have also ensured that there is the best SQL and Sparkle interoperability here. So the teams can work with both structured and knowledge graph data using the familiar tools in the Sparkle world. And also looking ahead, just a couple of things to mention. We are planning to roll out the LangChain plugin, which will make it easier to integrate with the generative AI applications. And we have a planned capability to also convert the property graphs to knowledge graphs, which is scheduled for Q3 2025. So I think that was all on this slide. And moving on to the next slide, we already did discuss a little bit about Sparkle. So a little bit of introduction here. Sparkle is like this query language that is designed specifically for RDF data in Knowledge Graph. It is just basically like the SQL that we use in the relational database. So Sparkle is used to, here in the sense, is used to retrieve and manipulate the Knowledge Graph data. So it would allow you to ask n number of complex questions to your complex knowledge graphs. Just as a quick example of how it would look like, just a syntax example there. Let's say I have a basic query: which movies were directed by Steven Spielberg and released after the year 1995? So the query is somewhat structured like this with the knowledge graph twist. So we definitely have the select movie and the release year that would define what we are basically looking for. And then we have a from a block where the graph from which knowledge graph are we gonna select the movie and the release year. We are specifying the knowledge graph there. And then we have the where block where all the conditioning is put in, like it defines all the conditions, like just telling here, like we are looking at the entities of type movies, and that has Steven Spielberg as a director, and then we filter for movies that is released after the year 1995. So this is basically how a Sparkle will look like, and going forward, we will see how it's going to be embedded into the SQL scripts. And just a couple more slides to just break down each of these new functions. I'm not going to spend a lot of time here. So first and foremost, we have the Sparkle Execute, which is a built-in SQL procedure. It's going to allow you to execute all types of Sparkle statement, like it could be select, insert, or delete, or load statement from the Sparkle side beneath it. So it's definitely bridging a gap here between the SQL and the Sparkle layers. And on the next slide, we have the Sparkle table, which is a HANA table function. Again, so we have to be sure that under a Sparkle table function, you can only execute a Sparkle select statement. So it's going to select, you use a Sparkle select statement and select particular set of filtering attributes from your knowledge graphs, and it will be returned back to our customers on the SQL layer in a form of tabular structures. So we will also see that in the demo in a bit. And on the next slide, we have the last function that's coming out. That's a SQL table function, which is basically allowing you to embed the SQL queries directly within the Sparkle statement. So you can see that here the syntax looks a little different. If you, Susan, if you could click on one more time, I think. Okay, I think the syntax. Okay, there we go. Okay, so we have a different looking shell on top of our normal SQL query that we have, like select 10 cross 10 as number from dummy. That's our SQL query, but it's embedded under a Sparkle layer. We will also see this in the demo in a much more like a vector similarity search kind of a scenario. And I think a couple of slides more to finish off. How do we basically enable the knowledge graph engine in HANA Cloud? So we have to enable the triple store service when you are provisioning your HANA Cloud instance in the SAP HANA Cloud Central tool. Once you reach the advanced settings step, which is the step 5, you will find an option to enable the triple store. As we see, we have highlighted it on the right. So it's just easy. You have to just check a box and be sure that you have more than 3 vCPUs so that the triple store engine or the knowledge graph engine is going to work efficiently. So this would ensure that your system has enough processing power to handle the graph data more efficiently. And absolutely, there is no extra licensing cost also involved here, which means you are all free to use the knowledge graph engine as part of your existing HANA Cloud license model. And last slide before I move on to my demo. So basically, we see how Knowledge Graph Engine now, along with the Vector Engine, is going to work together to provide some necessary context for the LLMs here. So as you can see, HANA Cloud here is acting as a core retrieval system, which is supporting multiple techniques like the text to SQL, which is translating the natural language queries into SQL for the structured data, and full text search, which is enabling the keyword-based lookups across structured text data. And then we have the vector search, which is retrieving the semantically relevant content from the unstructured data. And then we have the text to Sparkle, which is allowing the natural language queries to fetch the knowledge from the RDF-based knowledge graphs. So that is in a nutshell of how HANA Cloud is definitely going to power the context providing for the large language models. And with that, I will move on to my demo screen. To start off with, I'm now going to be creating a knowledge graph called as the KG movie. So I will be using the Sparkle execute built-in procedure in HANA Cloud, and the insert part that we see here, the entire script I have written down is all in Sparkle, just explaining the SQL and Sparkle interoperability, just as an example. So in my KG movies knowledge graph, I'm going to be inputting some movies, the name of the director, the release year, the genre that it belongs to, and also a one-liner about their plots. So this is what I have given as an input, and let's just go ahead and create that knowledge graph. Okay, now we can see that the knowledge graph is created, but let's go and check how this knowledge graph basically looks like. To give an example on how the knowledge graph could be retrieved via SQL and how it would look like as in the form of tables. So as you can see here, I have now retrieved my knowledge graph in the table format. I have used the Sparkle table function, which is again running as a Sparkle command inside it. And Sparkle table is my built-in SQL function that is rolling out new with the knowledge graph engine. Okay, let's skip to the next part of the demo where I want to merge the knowledge graph along with the similarity search results. For that purpose, let me go ahead and first drop any of the tables that I might have in the beginning. Okay, so first and foremost, I'm going to be creating a new table that would extract the movie information from my knowledge graph, also including their plot summary and so on. So let me go ahead and create a table called as KG search lookup that we will use further to run some semantic and similarity searches. So once my table is created, we'll just go ahead and see what is there in my table. So as you could see, I have retrieved the information about the movie, the director, the release year, and plot, all in the format of tables, even including their genres at the end. And now I'm going to be embedding this plot column into the vector format, for which I will be using my in database embedding function. So I'm going to be also adding a new column that will hold these vector embeddings in the same table, kg search lookup. So as a result, so it looks like a new column is added, which holds now the vector embeddings. Let's just take a look at it. So as you could see, I have my new column, and the plot has been vectorized in-house within HANA Cloud on the fly. And as a last part, I would want to, achieve the semantic search with using both the vector and the knowledge graph data that we have. For that purpose, I'm going to be running the Sparkle execute built-in function. And inside it, as you could see, I'm going to use the SQL table function, which is basically I'm running a SQL table command inside a Sparkle query, as you could see. So in here, I'm going to be I'm going to be running the cosine similarity, searching for all the movies that has or built up on the theme of having a computer hacker in their plot. So let's go ahead and run that script. And I'm also specifying that I want the results in a CSV format. I also want the scores, the similarity scores to which they have a match with my query. So I have got my results now. As you could see, I have 4 movies that match with my query that I had, like the computer hacker, and it's the movie Matrix, the Ghost in the Shell, Inception, and Ex Machina. Also the scores, the similarity scores to my query vector. And I think with that, I'll stop sharing my screen and would want to hand it over back to Christoph. Sorry for taking a lot of time here. Christoph, the stage is all yours.
Thank you very much, Shabana. So let me share my screen. All right. Thanks. And I'd like to share now an update on the new capabilities in the area of our machine learning functions and libraries, text processing capabilities, and also announce our brand new generative AI toolkit for SAP HANA Cloud, more targeted for machine learning, generative AI assisted scenario development. So let's take a look at those new capabilities. As a brief overview, as part of the predictive analysis library, there's certainly, again, a set of continuous enhancements. One of our prime time algorithms, hybrid gradient boosting trees, includes an optimization for HGBT-based time series forecasting scenarios for more robust forecast models where the data has not been part, or kind of patterns in the data have not been part of the training data. And also the AutoML enhancement is kind of targeted for time series scenarios using AutoML for time series, where the hyperband optimization helps for faster random search conversions to the best possible model. Also something our time series forecasting stakeholders would like to make use of. Our multi-layer perceptron neural network implementation, the multitask version of it, is now also being included in the unified regression and classification functions to be used. And also, as part of that, now supports the full explainability capabilities there. So you can reasoning on why a predicted value was kind of calculated. Our text keyword search-based function BM25, which we released in Q4, has been enhanced on capability to pass in a complete sentence as the input to this BM25 search. So also minor enhancements too. Now, really new side enhancements to the predictive analysis library, or in addition, is the document filtering library. a new plugin to HANA Cloud, which we'll talk about in a second in more detail, as well as the generative AI toolkit. The automated predictive library, as you can see on the right-hand side, is also released with a new version, 25.02, with some time series and memory consumption improvements. So the machine learning client HANA-ML in the version 2.24 also provides, again, a set of new capabilities in the area of using vectors with data frames and searching against those directly, creating indexes. As you can see, AutoML has been improved for massive scenarios where we run multiple AutoML searches in parallel on subsets of the data, as we call it data parallel or massive invocation, where our monitoring UIs have been improved to service those scenarios. And then maybe the third major enhancement there is that the text analysis capabilities are now fully available with respective methods in the HANA-ML client. Once released, once HANA Cloud is released next week, they will also share kind of the notebook example with kind of more details on each of the new capabilities. So the document filter library as kind of one of the key enhancements provides a capability which is also available in HANA on-premise, which basically helps to extract text from documents or binary files, if you want. If we have stored in HANA Cloud tables, as you can see it here on the right-hand side, 6 rows where we have blob entries in those rows in that column C. And by using this new function, DFL extract from text documents, we can basically extract this textual information from those documents. In order to make use of this new function and library, you need to kind of update your configuration of your HANA Cloud instance, as highlighted here by the screenshots on the left bottom side. Selecting this new plugin, the document filters library. But now let's come to the generative AI toolkit for HANA Cloud. This is kind of a new Python package which we have open sourced. So it's available on github.com SAP generative AI toolkit for HANA Cloud as a means aiding data scientists and developers to use a generative AI agent-driven development experience for HANA-ML-based capabilities. What you can do with this generative AI toolkit, you can build your own knowledge stores with best practice templates, or use the 300 templates we provide out of the box. And what we've been adding and will be enriching more and more are specific HANA-ML tools. Tools from templates are distinguished as tools are executable kind of objects, providing insights and information on themselves, and they are can be directly used by the agent, whereas the code templates rather serve the code generation scenarios compared to the tools, which actually their target is to be executed by an agent independently. So therefore, also a conversational agent is one of the key capabilities, which we'll see in a second in the demo. It's called HANA-ML agent with memory. It's based on a LangChain agent framework, and as said, primarily it utilizes the HANA-ML tools which we provide for executing independently and some more self-sustained. It focuses for now on forecasting scenario, but we will enrich the same with more and more tools. There's a set of other interfaces and agents which make more use of the code template side of the toolkit. So they target more code generation and execution based on the templates you provide. So there's a data frame agent where it all starts with a data frame, or a SQL agent, which is more about then generating SQL code based on your code templates. and also a conversational data frame, which is more than, let's say, an interface. You can ask it or to execute some task against your data directly. And as said, it's already published on github.com, so you can take a look there, including the documentation. But let's look at some of more details here. And there's this first step where you would create your knowledge store from templates. Then you could basically load the tools into a toolkit object, and that's what we'll see in the demo in a second. And basically then make use of it as part of such a conversational agent. And as we are kind of short in time, let's directly jump into the demo. So I have now two packages, not only HANA ML, the machine learning client, but also HANA AI, which is the generative AI toolkit, which I'm loading. As I'm using large language models via the Gen AI Hub, I need to load the respective connectivity and libraries with the generative AI Hub SDK. I'm connected there, I'm connected to HANA Cloud. And now what I'd like to do is build a forecast model based on my data, which is sales refunds data. So I have for every day, I have basically one refund figure over the time of 5 or 6 months. And as indicated on the slides, first thing, I'm loading the tools. All the tools we provide targeted for forecasting scenarios in the beginning. Then I'm basically building my agent object or instantiating my agent object. And from there on, I can basically talk to it and instruct it to do something. And it will use the tools which we have provided at best to conclude kind of the result. So for example, show me the first 10 rows of the sales refunds table. Secondly, show me a dataset report, and it basically will call the tool which generates the HANA ML report object. And this takes a second, but I think it will conclude shortly and show the report. Let's give it another kind of breath, and here we go. The report is already loading. Actually, it's not too big, so maybe that's kind of a bandwidth issue here right now. And basically, simply by this natural language instruction, it basically executed the tool and created the report for me. Now, as I'm not a data scientist, I don't know kind of which algorithms should I use to build this forecast model. So please analyze and check my time series data and give me some indication. Is it an intermittent time series data? What trend is there, etc.? So there's some indication. Again, I'm not a data scientist, so please tool, make use of this information yourself and propose me an algorithm to build the forecast model with. Let's see if it can reason to make use of a specific algorithm. And here we go. It suggests to use the additive model forecasting algorithm, also known as profit model. So, hey, you found it out. Now build the forecasting model yourself on the algorithm you suggested. And there it is. It has built the forecasting model. Let's apply it to my prediction data, which I've prepared here in the sales refund predict table. Let's see, it can also, yes, it applied the forecasting model. And finally, what we'd like to do is, again, create a visualization for me to better understand how the forecasting model looks like. And here we have the presentation of kind of the data we use for training. And here on the right-hand side, the actual forecast itself on the new days in the month of October 2024. And as you can see, there's kind of in the second week of the month, there's always this peak, and our profit model nicely predicted this pattern. And finally, as we want to integrate such a forecasting capability into an application, there's the last task, or one of the last tasks is here to then also generate the SQL artifacts, which we can then pass on to the application developer to include that into the application. As we can see it here, it generates me the CDS artifacts and also the SQL artifacts behind kind of the model I've just created. Yeah, this is the introduction to the Generative AI Toolkit. And with that, I'd like to pass it on to Jan. Thank you very much.
Thank you very much, Christoph. So thanks everyone for joining. The next topic will be about calculation views, so a way of doing analytics with SAP HANA Cloud, using, for example, tooling like SAP Analytics Cloud, or also third-party tools like Tableau or Power BI. The first topic is about variables, where we introduced a new type of variable called derived variable. The idea here is that you have an option now to specify a data source that provides filter values that are then constructed by the analytics tool at query runtime. Now that sounds very difficult to understand just verbally, so just let me show you how this looks like in the system. So what we have here is we have here a variable defined. It's of type derived. And we say, look at this data provider, which is a source that provides a tabular data. Take the values that are contained in this column and apply these values as a filter on this attribute of the calculation view. So if now the analytics tooling is run on this calculation view, then a SQL statement, like for example here, is constructed where you see the filter is applied to the column city based on the values that are delivered from this data provider. So with that, you have an easy way or flexible way at query runtime to determine how your filter should look like, depending on what values are in your filter value provider. The next topic that I want to talk about is about the option now to copy calculated and restricted columns as well as input parameters. You could do that already in the past, as long as you copied within a calculation view. We now allow also to copy and paste between different calculation views. And if in the target calculation view, some dependent objects are missing, then you are notified during the copy process. So let's just do a quick example here. So I have here a calculated column. In this calculation view, I select the copy option. I go to the target view, again to the calculated column tab, and I use the paste option. And now I'm notified you are pasting this calculated column, and actually it's depending on column C2, which is not in the target view. So now the calculated column is copied, but if you have to solve somehow the dependency and decide on which other column you want to depend this calculated column on in this new view to which you copy it. Okay, we introduced a new option to clean up intermediate data preview objects. So the background here is that if you start an intermediate data preview, temporary objects are created. These temporary objects are required for the intermediate data preview. And the issue is now that from a database perspective, we cannot determine when a session is finished where you want to do the data preview. So these objects remain and are cleaned up as soon as you redeploy your calculation view. Now we offer a dedicated option to clean it up on purpose at that time that you want to execute the cleanup option. And this cleanup option becomes available if you use the data preview with other database user. So this can be, for example, helpful if you are in a firefighting situation where you are debugging in a productive environment and you want to make sure that intermediate data preview objects are cleaned up as soon as possible. So let's just look at how it looks like. So let's say I do here an intermediate data preview with another user. Now I select my service that I want to use, and now I have here the option of clean up for this dedicated schema for which my service has access. Now, at the moment, there are no intermediate data previews because no intermediate data preview has been run. So let's just do that quickly. I run an intermediate data preview. So now in the background, intermediate objects are created that are used for this data preview. And if I now start a new data preview with other database user, and I use the cleanup option, then I see here the remaining object from the intermediate data preview, and I can just clean it up. And I get a success message, and I'm done here with cleaning it up. The next feature is about target feature version. And here the idea is that you are working often in an environment where your development system has a different release than your productive system. Might be higher. So what you want to avoid is that you have some features developed in the development system that are not available already in a productive system. And with this new innovation, what you can do is you can, so to say, freeze the database version in your development system so that in a HANA modeler, only functionality becomes available that's also supported in a productive system. So you basically say in a development system, this is the target release version that I want to develop for. If you do so, you would go here to the database module and say maintain modeling feature set. So the first time you do it, you have only the option to choose the release of your current database. So you freeze it now at that version. And now let's say you upgrade it in the background. And then the next time you open it again, you will see that now you have the option to select a release between the last frozen version and the current database release. So I manipulated the database in the background here to pretend it's a higher release actually. But the normal workflow would be you freeze it at a database release, and then after an upgrade, you stay on it until you select another version up to the new database release. We also support now vector embeddings in expressions. So here, just to also show that, we have here a calculated column and we do a cosinus similarity. The important point is if you go now to the functions in expressions, we also support several different vector functionalities. So just as an example, you can now do a similarity search between your input parameter query and what's stored in the database table. So for example, here I'm asking who is doing the calculation view session, which is not updated at the moment. And I can also ask for when is the calculation view session. And then you see the similarity here of the different answers. I mean, this is now just a toy example, but I think it should be clear what you can achieve with that. You can compare based on a similarity search between the embedded vector of your input parameter and the data in a database table. Now, time is running short, so let me just quickly mention that we also added some additional execution hints. If you, for example, go here into the view properties, and advanced, and you select here the execution hint option, then we have here now new execution hints that you can just select and add to the calculation view. And with that, I'm finished with my topic and hand over to Jose. Thanks for joining.
Hi everyone, and my name is Jose, and I will be showing you the new Gen AI virtual assistant that we release in our product. Here we are. Okay, so what exactly is the Gen AI virtual assistant in HANA Cloud? It's a virtual assistant for HANA Cloud administrators and operators that will allow you to execute operational tasks through conversational chat. And the tasks that you can do include navigation to different applications in the HANA Cloud Central tool. You can also ask any questions about using HANA Cloud Central in a virtual assistant. You can generate SQL statements from the text queries that you are going to enter into Virtual Assistant. You can actually generate as well a summary for both alerts and issues in your HANA Cloud instance. The Gen AI Virtual Assistant currently is powered by Joule with limited features. That is what we call the specific capability. What this means is that Joule with limited features is a reduced feature set of the capabilities that are provided by the Joule web client. Basically, if you want to know what the list of the limitations are, there's a link here to the help portal when you can find out what they are. But that is something that people need to understand, is that it's powered by Joule with limited features and it's specifically designed for HANA Cloud Central. Now, the Gen AI for HANA Cloud Central is only available in BTP data center deployments where SAP AI Core Service is available. So it's not available in every single landscape or data center. So there's an SAP note here that you can take a look for the complete list. If you're running HANA Cloud Central in a data center deployment where SAP AI Core Service is not available, then you will not be able to turn the feature on, which is what I'm going to show on the next screen. And yes, in order for you to use the Gen AI Virtual Assistant, you need to enable the feature in HANA Cloud Central, and the way you enable it is by going through the user settings and enabling it there. How do you do that? This is the procedure. So in HANA Cloud Central, you need to launch the settings application on the top right on your user settings there. You click on your username and then you go to the settings tab. And in there, you're going to get a dialog for the settings and you're going to see a new entry on a dialog. It's going to say Gen AI. Again, if you're running HANA Cloud Central in a deployment landscape where SAP AI Core is enabled, then you're going to see it. If SAP AI Core is not supported, then you will not see it, the Gen AI tab. But once you go to the Gen AI tab, you click on it, and then you're going to get a dialog where there's going to be a toggle button where you can enable the feature. So you switch that on. When you click on, when you toggle the switch on, you have to read and accept the AI terms and conditions. And once you do that, you save your changes, and you have the Gen AI Virtual Assistant enabled. All right, so then, and if I look over here, it looks like this at the bottom here. And you're going to see that icon, which is the Joule icon, appear in the HANA Cloud Central, the top navigation bar or the toolbar. Now let's take a look at the functionality that is provided by the Virtual Assistant. As I mentioned, you can perform navigational tasks or navigate to different applications in HANA Cloud Central, depending on what you're asked. So here's some examples. For example, you can tell it to go to the SQL console and navigate there, or tell it go to database objects or go to migrations. That's very specific prompts that you can provide. You can also ask the assistant to give you help regarding a specific task you want to do. For example, you want to maybe create a new user, or you want to monitor performance of your instance. You will type that in, and then the response that you're going to get back would say, okay, in order for you to do that, you need to use this tool, and it'll give you more information about the tool. And then you'll probably get some buttons to navigate to the tool as well, right? So you can explicitly navigate to a specific application, or you can specify what you're trying to do, and then the assistant will be able to tell you what or where to go from there, and then you can navigate to the application. That can be handy in case you don't know the name of the application, or in case we have new applications that come into the product, and then you may not be aware of them. The assistant will be able to tell you at least that this exists, and then you can go and try that out and do your operation from that application. You can also craft SQL statements, and here's a couple examples of SQL statements that we've entered. For example, how do I change a user's password in SQL, or giving a SQL to see all the connections for a specific user that are running. And when you do that, then you're going to receive a statement that you can copy to the clipboard, or you can open the statement in the SQL console. If you open the statement in SQL console, just make sure that you're connecting to the right instance before you run the statement, and then you can click the run button, and then you can execute it. Now, the SQL statements that we support are currently we support SQL statements for the system, the monitoring views, and the internals of the database, of the actual database. That's what I mentioned, system views. We don't support customer schema, not yet. That is something that we are planning on supporting later this year. And the other piece of functionality that we can do is to generate summaries of issues for specific type of alerts. The three that we support right now to generate a detailed summary is for out-of-memory alerts, block transaction alerts, and delta merge alerts. This is how it looks like, where in the virtual assistant, you can ask about the alerts. The virtual assistant will tell you, I found some alerts, here they are. And then you can look at the alert list. And then when you look at the alert list, you can invoke a pop-up menu and specify to troubleshoot the alert. When that happens, then we are going to generate a summary, and that is based on GenAI. And the summary will get information from a vast variety of sources, the user assistant, SAP notes, what is happening inside the database, and it will give you information about that issue in a recommendation. In this particular example, there's a long-running blocking transaction or situation that occurred, and you can see if you can. It's a little bit difficult to read, but basically what the assistant is telling you that this was an isolated incident, and that is there might be no need to do any further based on that, but you can troubleshoot the issue a little bit more and give you some recommendations in there. That would be different if the situation was occurring at specific intervals. Then the assistant would tell you that, hey, you may want to take a look at the following recommendations based on the frequency of where this alert is happening. So the assistant is smart enough to give a recommendation based on the frequency and always on the alert that is given to you. And again, that is based on what is happening inside the database. Here's another example. This is about out-of-memory error. And basically, the idea behind this, showing you this, is that the analysis summary is obviously different depending on the condition that you have, and it's different based on the sources of information that the assistant is pulling the information and is sending it to the model to receive back a response that is appropriate for you to consume, and that allows you to troubleshoot the specific alert. All right, so that was all I want to cover up with the virtual assistant. If you have any more information, or if you'd like to know more information, we have SAP notes and a lot of information on Help Portal and the community that will teach you or give you more information about the assistant. With that, I'm going to turn it over back to Susan.
Perfect. Thank you very much, Jose. And thanks also to all the other speakers. We do have a few seconds left. So let me use these few seconds to first of all say a big thank you. This has been great innovations, great demos, and we definitely do have more innovations coming with our QSE1 release. If you want to get a total overview, definitely check out our technical documentation that covers all the details. And we also, as always, release a bunch of contents with the release. So definitely have a look at our teaser, our blog post. There is also one specifically talking about the calculation view features Jan introduced. So Make sure to check all of these resources out. And with that, thanks for joining us today, and see you next quarter. Thank you very much.